Alright, okay, so today the question says find the value of the remaining side and angles to two decimal places. So we're given a triangle. We don't know anything about this triangle, if it's equilateral, but it's definitely, I suppose, not equilateral because this is 9 and this is 10. We don't know if it's isosceles. We don't know anything really, okay? But we're asked to try and fill in the blanks. So we want to try and find this side and we want to try and find these two angles. So we have one method so far in our bank of knowledge, and that is the sine rule. So the sine rule, you should know at this stage, is all about pairs. It's all about picking pairs that work together and that you can figure out. So in the log tables, the sine rule is the sine of little a over big A, which is obviously the angle over the side, which is equal to the sine of little b over big B, which is equal to the sine of little c over big C. It can also be written as big A over sine A, should have done that, equals big B over sine B equals big C over sine C. And just remember that if it is a capital letter, that stands for a side. If it's a small letter, it stands for an angle. So I'm looking at this triangle here now and I want to pick pairs, okay? So I can spot that the 60 degrees and the 10 centimetres, if that was capital A, that side was capital A, this would be little a. So they are a pair that match. Obviously I only have one other piece of information, which would be this 9 centimetres, and I would, using the sine rule, be able to find its pair. As long as I have a pair that matches, I can find the other pair. So that's what we're going to do now. Now you might ask, well, which one do I use? Do I use this one or do I use this one? So obviously we don't need the sine C because we're just focusing on 4 pieces of information here. And so I always say, always put what you're looking for up in the top. So you can see I'm looking for, we're going to call this x, and it is an angle. So if I'm looking for that, I'm going to use the angle on top here. So I'm going to say the sine of x all over its pair, which would be 9, equals, and then remember this pair has to be the same. So if I've gone for the angle on top, I must continue to go for the angle on top. So I'm doing sine of 60 all over 10. Now the only reason why that helps is because when you're cross multiplying, it means you're going to have you're not going to be dealing with fractions later on, but that's essentially how you would apply the sine rule. So you can go angle on top over side, or you can go side on top over angle. I would always look and see, what do I want to find, and I would always place that on top here. In this case, I want to find this, which is an angle, which means I'm going to use this top one here. So it's angle over its pair equals angle over its pair. So at this point here now, just making sure your calculator is in degrees, you can figure this out. So we could get sine of x is equal to 9 times sine of 60 all over 10. And you can type that into your calculator and you might get sine of x equals 9 root 3 over 20. But of course I'm not asked to find sine of x. I want to find this angle in here. So it's sine to the -1 on both sides there. Okay, so that should be sine to the -1 of sine of x. So they cancel, and I'm left with x is equal to sine to the -1, 9 root 3 over 20. I suppose keep those in brackets. Type that into your calculator. You should be doing this with me to just make sure that you're getting the right answer. And I'm getting x is equal to 51.21 degrees. Now, in this question, I was asked to find the values of everything remaining. So I'm going to just rub out all of the markings that I've made so far. I've just found out what x is. X is 51 degrees, 0.21. Okay. So obviously the next thing I want to find out is this angle here and this side. So finding out this angle is actually going to be quite easy because we know all angles in a triangle add up to 180. So that should tell me what this angle is here. And if you do that, if you add 51 and 51.21 and 60 and subtract them from 180, you should get 68.79. Okay, so we can immediately see that this angle and this side are a pair. And we're going to use sine rule again to try and solve that. So the sine rule is all about picking out pairs. So you might be saying, well, which pair do I pick out? Do I pick out the 9 centimetres and the 51.21 and do I use that? Or do I use the 60 and the 10 and use that? But obviously this is mathematics and it is mathematically correct to use either there. It doesn't matter because it will work out. So look, I'm going to go with the 68.79 and the x and the one that I've just labelled there, the 60 and the 10. So you have to say to yourself then there, so I'm going to take, no, it's not really. Okay, give me a second. Okay, so I've just zoomed in on my diagram and I brought it here. So as I said, we're trying to find, we've actually got all the bits of information now bar this last side. So that's what I'm looking for here. I'm looking for a side. So which sine rule am I going to use? I'm going to use the one that has the side on the top and then the angle on the bottom equals the side on the top and then the angle on the bottom. We only need 2 pairs for the sine rule. So I always put what I'm looking for up on the top here and I'm looking for x. So it's x over the sine of the angle that associates with that, which is the sine of 68.78 equals, and then b and sine b is just another pair. So I'm going with this pair here, the 60 degrees and the 10, they're a pair. So I've obviously gone, if I've gone for the side on top here and the angle on the bottom, I must do the same here. So it's going to be the side, which is 10 all over the angle, which is sine of 60 degrees. Now, so we're just going to do a little bit of working out here. We're going to multiply this side by sine of 68.78 and then we're going to multiply this side by sine of 68.78 and then just, I suppose, keep things in brackets to make sure you go right. So they're going to cancel and I'm going to be left with x is equal to sine of 68.78 bracket 10 all over sine of 60 degrees. Okay, and you can type all that into your calculator, it'll do everything for you, and you should get x is equal to 10.76, and we are given the units in this question, so it is centimetres. Alright, so just a little bit of looking at the sine rule there and looking at a question that might involve a little bit of work. But that's not actually what today's lesson is on. Today's lesson is more on the ambiguous case, but I just wanted to go through that question with you anyway. So, moving on. Okay, the ambiguous case. This is if you are given 2 sides in a triangle and 1 angle and you're asked to solve. The ambiguous case means that there may actually be more than one answer for this. So I'm going to show you how we calculate the second answer. So again, the ambiguous case is just for Leaving Certificate higher level, okay? All right, so what am I going to do first? I'm going to figure out the unknown sides and the unknown angles is what I'm asked to do. I have this, that's a clear pair there, so I have a matching pair. So the only other pair I could find is this one and this one. Okay, and I'm obviously looking for an angle up here, so I'm going to call that x and I'm going to use my sine of x, so that's what I'm looking for, all over its partner or its pair, which is 17.6 equals, and then if I've gone for angle on top here I have to go angle again on top, so it's sine of 48 degrees all over 15.3. Okay, so I'm going to multiply both sides by 17.6 and I'm going to get sine of x equals, because they're going to cancel, 17.6 sine 48 all over 15.3. Can type it into your calculator and you're going to get 0.8549. And remember that that is sine of x, but we're not asked about sine of x. We want just x. So sine to the -1 on both sides. So I'm going to get x is equal to sine to the -1 of 0.8549. And then I'm going to get x equals to the nearest degree is 59 degrees. Okay, so I want us to think to our work that we've done on the unit circle, because this is why this will be important, or one of the reasons. It's actually very, very important, but one of the reasons. So I have my unit circle here, and how we remember it is the words cast. So C-A-S-T. So we know in the A bracket, everything is positive. In this section here, in this bracket here, sine is positive. In this one here, quadrant, tan is positive, and in this one here, cos is positive. So if we get x is equal to 59 degrees, if you were to draw 59 degrees and that was your base there, it would probably look a little bit like this, 59 degrees. So that's it. X is 59 degrees and it's in the first quadrant. But remember, it is sine. So where else could 59 degrees have happened and been positive? And it actually could happen here, in this case here, in the sine one. So if that was 59 degrees, if that was where it was drawn, it would be positive and it would work. So then I would be asking you, well, what is the remainder of the angle then? So we know that the straight line here is 180. So the remainder, so where the red is here, would actually be another angle it could be. So technically this angle could be x is equal to 59 degrees, or it could be x is equal to 121 degrees. So how are we going to find the third angle there? We're going to actually have to do the third angle twice. Once assuming x is 59 degrees and once assuming x is 121 degrees. So the ambiguous case is super important, and you know, if you're given two sides and an angle, that is when the ambiguous case you may need or will need to happen. So two sides and an angle, that is super important. That is when the ambiguous case may need to come in. So as I said, now I've got two answers. So I'm going to go back. I'm going to take the question and just put it down here. So give me a sec. All right, okay. So I'm going to fill in what I know. The first time I did this, one of the answers could potentially be 59 degrees. So I'm putting 59 degrees up here. And now I'm going to, if the answer was 59 degrees, I'm asked to find all angles and all sides. So I would be able to now find this angle. So I'm adding 59 degrees and I'm adding 48 degrees. And I'm going to get that this is going to have to be, well, this could be 73 degrees. Okay, and I'm going to now find the third side. So remember, it's all about picking your pairs. It doesn't matter what pairs you pick. Obviously, this is what I want. So I'm going to have to use this pair here. So remember, I'm looking for a side. So that's going on first. So x over the sine of 73 equals. Now, do I pick 59 and 17.6? Or do I pick 48 and 15.3? So it doesn't really matter here. I'm going to go with 48 and 15.3. But again, mathematically, it should be fine. But I suppose I would pick this one because we are definitely told this information in the question. Whereas potentially this could be 121. So that's probably why I'd veer more towards this one. Okay, so now it is going to be 15.3. So remember, if you've gone side on top on this one, you have to do side on top on that one, all over the sine of 48 degrees. So we're going to work that out as we would normally, bring everything over, and I'm going to get x is equal to sine, well maybe we'll write it like this. So 15.3 bracket sine 73 all over sine of 48, and you type that into your calculator and you're getting x is equal to 20 meters. So potentially that could be 20. However, remember we said that when we got 59 degrees, it could work in this A circle, the all circle, but it could also work in the sine circle here. And if it's in the sine circle, it means the actual angle would be 121 degrees. So parking all of that, we're now going to go back, and my triangle would look a little bit differently now. It's not going to look like how I would have expected it, because I have my 48 degrees here, but up here I have 121 degrees. Was it? Yeah, 121 degrees. So in actual fact, I think my triangle is going to be a little bit like this. That's what it's going to look like. And I can fill in some bits of information that I know. So I definitely know that this here is 15.3. And this one down here is 17.6. So if that's the case, I'm asking now to find this angle here, which I can find, sorry, I better put a little blue mark on it, this angle here, which I can find easily enough by adding up. Now, see, if I added up these and they were too big for 180, then we would know that 59 is the answer completely, okay? But when I add up 121 and 48, I still have 11 degrees left, so potentially it could work. And so that's why also the ambiguous case is important, that if you get quite a large number and it won't work into 180, then you can know you can stick with just the first one. But many times at Leaving Certificate higher level, there will be duplicate answers, okay? So it is something we're going to have to get used to. Alright, so now on this triangle I have lots of information. The only bit I don't know is this side here, which I've called x. So I'm now going to do the sine rule again. So I'm doing my pairs. So x over sine 11 equals either pair again. I'm going to use the same pair again. So 15.3 all over sine of 48. Now multiply both sides by sine 11. They cancel, and on this side then I'm left with x is equal to 15.3 bracket sine 11 all over sine of 48 degrees. And if you type that into your calculator, you're going to get 4 meters. X is equal to 4 meters. So we have two answers there. So that angle there can change. It can be 59 or it can be 121, and the side can actually be 20 meters or 4 meters. Both of those answers will satisfy that triangle. So that's the ambiguous case, and quite common in questions to do with trig. Okay, so learning check on the ambiguous case. This is actually question 1 in exercise 7.8 part 3. So if you do want to check your it's exercise 7.8 if you do want to check your answers with the back of the book, but this is the learning check. So again, we have two sides and an angle. So you're thinking to yourself, does the ambiguous case follow here? And so just be conscious. And some of them, when you get an answer, like obviously say if I got quite a high answer here, then we would say, or sorry, quite a low answer here, and the third angle then would be bigger than 180, we can say that the ambiguous case is not the case. However, this question is actually an ambiguous case one, so good luck with this one.